Let's do this Kirby-Bauer assay. Very straightforward. So when we look at what we've got here, we've got our 3 antibiotic discs. We've got our relatively fresh Staphylococcus epidermidis culture. And so this is now about 48 hours old. We've got our tweezers. We've got our hockey stick. It's also called a bacterial spreader, but a lot of professional microbiologists call this the hockey stick because of its shape. We've got our flame, and we've got our plate, which we have already labeled according to the directions. So let's go ahead and do this. So the first steps are to get 8 drops of this culture onto this plate, again, which I've already labeled according to the instructions. And so the flame, of course, is to hit with the opening of the tube. And so a little bit of inversion, open that up, give it a quick little flame. Sterile pipetter. And now I'm just going to go ahead and pull up some. Now you need to do this, don't rush. You never want to rush in microbiology, but you also don't want to dilly-dally. Okay, so when I take this now, I'm going to go ahead and put this, and I'm going to go ahead and drop 1, 2, 3, 4, 5, 6, 7, 8 drops, according to the instructions. I'm just going to put this back in here for the moment, because what I want to get doing right away is getting this sterile hockey stick out. And so now what we're going to do is essentially spread the solution all the way around so that the liquid sucks into the Petri plate. Okay, so the agar should be dry enough so that it actually sucks up the liquid. And what I can see with my eye, I don't think the camera's picking it up as well, is that I still have some, I'm looking at an angle, I still see that I'm moving liquid around. As long as you're still moving liquid around, you keep moving this hockey stick. Okay, that's the key. And you want to make this nice and even across the whole plate. And so just do it randomly. Do this. In the microbiology lab, there's actually a spinning platform that you put this on, and you can spin it, and then the plate spins around, and you just move the hockey stick around, and that works really, really well. They are surprisingly expensive, as most things in science are. But you guys are just doing this one plate, and so it really doesn't take that much. Okay, now what I can see with my eye is I can see that there's a lot less liquid being pushed around. And oh, right now, it's dry on top. So that takes care of that. So I'm going to go ahead and close this up. The hockey stick, it's a one-time use. I'm going to go ahead and stick this into the bleach bucket. There we go. Die, 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 Staphylococcus epidermidis. That's all we need from this. So I'm going to do the same thing with my pipette. I'm going to get rid of what's in there. Then I'm going to go ahead and pull up bleach into the squeezy bulb, do that several times, leave it in the squeezy bulb, and then leave it in the bleach. Close this up. And then the directions say to wait 1 or 2 hours. You can do that. You really don't need to. When I'm looking at this right now, I see that it is completely dry on top, which means that it completely absorbed. If you're looking at it and it still looks moist because maybe you just made the plate a little while ago, then go ahead and wait an hour to 2 hours, okay? So you don't want to rush it, but if you don't need to, you don't need to wait. And so I don't need to wait. So if you're concerned, or you just like, I need to stick to the 1 to 2 hours, or if you see any kind of liquid on top, then wait, okay? But I have the benefit of being able to go and do this right now, okay? So we've got our 3 antibiotic discs. And so where I labeled it, so GNT, I'm going to find the gentamicin, okay? And now what you want to do is you want to put it right in the middle, okay? So I'm going to go ahead and grab the disc from, and actually one thing I can do too, so I can go ahead and just actually put it in the top of the Petri dish if I wanted to. Makes it a little easier to grab. And then take it, and then grab it nice and tight, kind of move it around. Like right now I see that it's not falling, so it's nice and tight, because what you don't want to do is just drop it willy-nilly. So now on my plate, I'm going to put it so that it is essentially, hopefully, like right in the middle. So, boom. And now I'm going to go ahead and press down gently. All right, so gently press down on it. What you want to do is you want to make that contact between the disc and the agar so that it sticks. That's what you're trying to do. This is a disc diffusion assay, so the gentamicin that is impregnated in that disc is now in contact with the liquid or moist agar, and the antibiotic is going to flow down its diffusion gradient, and it is going to actually go into the agar and spread out. And that is what we are relying on. We're relying on a gradient of antibiotic, and that will allow us to determine whether there is a zone of inhibition. Okay, so the next one, penicillin. Now, if you're allergic to antibiotics like penicillin, something like that, you're wearing gloves, it shouldn't be a problem. So just make sure that you don't handle it. If you have severe allergic reactions to penicillin, go ahead and don't use the penicillin disc, right? And just explain in your lab report that you didn't want to mess with it because you are severely allergic to it. And hey, I don't want you to do something like that. Okay, I'm grabbing the penicillin disc. Oh, see how it just came out? That's why I'm kind of testing it. All right, no, there we go. And penicillin. I'm going to go ahead and make it nice and tight on there. And then the last one is novobicin. And part of the lesson plan is for you to learn about these antibiotics, right? So the material, novobicin, right? Novobicin. So that's why in this video I'm not going to talk about it, because I want you to read the material and learn it well. I just want to stick with getting the lab stuff down. So this is nice and tight. Don't gouge it in there. Don't stick it in there. If you do press it too hard, so for example, I'll go ahead and do that. Like if you press it too hard, oh, and it just went in, right? So what we did is now I've got a disc that is partially in the media. Okay, so this disc right now is sticking inside at a weird angle. Just say, oh no, I'll put that in my lab report and I'll explain that I goofed it, and that's, that's fine. All right. Very good. So, close this back up. So now what to do with this, right? What to do with these tweezers, because we just touched the discs, which are fine, but then it came really close to the Staphylococcus epidermidis, right? So the question then is, what do we do with this? This is the only lab that we're going to be using this for, so as much as I hate to just be throwing things away, I'm going to put this in bleach, right? Make sure that if anything did touch that Staphylococcus epidermidis, then that staph epidermidis is going to die, okay? After it's been in there, what I'm going to do, though, is I'm going to go ahead and after it's been in there for 30 minutes, I'm going to go ahead and pull it out, and I'm going to rinse it off really, really well, really dry it, because the bleach should have killed everything. Okay, so everything that goes in the bucket doesn't necessarily need to go into the garbage, right? And so in this case, I may pull that out, but I don't think we need it for the rest of the lab. And so at this point, what we're going to do is take this, and the discs should be adhered nice and tight to it, so you should be able to turn it upside down like we do for all of them, put it in the incubator, and then incubate it for 24 and then 48 hours. Follow the directions on how to interpret it. Zones of inhibition are fun. What I'm going to show you right now is an assay I did with the same bacteria. I guess I should go ahead and close off that flame instead of burning my hand. All right. Do not leave a flame unattended, which I did not. Obviously, I was here. Okay. But if we look at this plate right here, it looks a little different because what I did for this is I used a swab. And you can do this in a number of ways, and I kind of wanted to show you the different ways. So this, I just put a swab into the culture and I swabbed around. And so what we're seeing here, and this is not Staphylococcus epidermidis. I wanted to use a different bacteria so that there were different results compared to what you get. Okay? So I will show you how to interpret this, though. If we look at this, if we look at all of this bacteria all over, that's growing everywhere. And if you can see on this particular disc right here, the bacteria grow all the way up to the disc. And so that antibiotic, penicillin, for this particular bacterium did not inhibit the growth of it. But if you look over here, do you see how there's that faint ring? That's what you're going to measure, that diameter. That is the zone of inhibition. And same with this, there is a zone of inhibition. Now, depending on what type of bacteria you use, sometimes these zones of inhibition can be massive. They can be huge, or sometimes there'll be none. So different bacteria have different susceptibility to different antibiotics. And for this lab, we're only looking at one particular bacterium, the Staphylococcus epidermidis. When I teach this on campus, we use Escherichia coli, we use Pseudomonas aeruginosa, and we use Staphylococcus aureus. And they all exhibit different properties because some antibiotics target gram-negative bacteria much more powerfully than they do gram-positive. And some antibiotics will inhibit gram-positive but not gram-negative. And then there are the broad-spectrum antibiotics that can kill both gram-positive and gram-negative. Okay? And so hopefully by looking at this, you'll get a good idea. This is the same type of assay that's done around the world. Now, when you do it for real, there's standardization, so you don't just take a culture that has whatever kind of growth in it that's turbid. It actually needs to be a certain level of concentration of bacteria, and everything is standardized. And then you use these tables to determine whether it is antibiotic resistant or not. So for example, when we're talking about MRSA, that's methicillin-resistant Staphylococcus aureus, but it's not only resistant to methicillin, as you'll find out in your readings, it's resistant to a wide number of antibiotics. And so the how antibiotics work is part of this unit, and how bacteria become resistant to antibiotics is another part of this unit. And both parts to this unit are so extremely important for healthcare professionals such as yourself. So I'm going to go ahead and incubate this, follow the directions on the analysis, and then I'm going to go ahead and clean up as normal. This culture, I'm still holding on to this, right? You always want some good working cultures, so don't get rid of that. So enjoy your antibiotic and antibiotic resistance lab.